we're jumping right into a totally revolutionary shift in how math is taught, experienced, and actually learned. Look, for decades, higher ed math has been kind of plagued by high anxiety and just really low motivation. It's a stubborn problem. But what if we completely flipped the script? What if we stripped away that constant fear of the wrong answer and instead empowered students to actually design mathematical meaning rather than just passively memorize formulas? The results we're seeing completely challenge everything we thought we knew about math anxiety. So let's dive into exactly how they pulled this off.
Here's a quick look at our roadmap. First, we'll look at the new paradigm of the student as an architect. Then, the incredible 94% motivation spark. Third, we'll unpack strategic semiotic competence. Fourth, the real-world skills achieved. And finally, why this leaves students so prepared for the future.
There is just a stark contrast between these two approaches. For generations, the old paradigm treated math like a rigid, finished product. It was essentially a fixed set of rules to be passively consumed. And honestly, it makes total sense that this transmissive approach caused so much stress and task avoidance. But this new paradigm, it totally reimagines that dynamic. It treats the student as an architect, an active designer of meaning. In this model, learning becomes this dynamic, creative process connected to the real world, and absolute student autonomy takes center stage.
All right, let's get into Section 1, a new paradigm, where the student is the architect. The real engine driving this whole transformation is something called the MHEA-M model, or the heuristic model for mathematics teaching and learning. Instead of just drilling the same procedures over and over, this relies on a continuous loop called action, reflection, action, or ARA. Basically, learners explore a contextualized problem, build their own preliminary models, and then refine those ideas through dialogue and peer feedback. After some deep reflection, they take action again to lock in what they've built. It's a recursive process that gives students what we call epistemic agency, meaning they go from being passive listeners to active creators of their own knowledge.
Moving right along to Section 2, the spark of learning and that 94% motivation rate.
So you're probably wondering, how do you spark genuine curiosity in a subject that historically just freaks people out? Well, the answer actually lies in multimodal visual artifacts. We're talking about intentionally bringing academic posters, mathematical memes, and even educational comics right into the core curriculum. By injecting these humorous, narrative elements, the perceived threat of complex math just plummets. It acts as an emotional catalyst, turning a high-stress environment into a highly engaging, culturally relevant space.
And this brings us to an absolutely massive metric, 94%. A stunning 94% of participants in this study reported a huge positive shift in their interest, motivation, and overall enthusiasm for the discipline. Just let that sink in. In higher ed math, nearly every single student felt newly motivated simply because the learning was reframed as a creative, dynamic process.
You can actually see this overwhelming agreement right here in the survey data. Those orange and red bars, that's students explicitly stating that activities like designing posters and using multimodal tools literally woke up their curiosity and completely shifted how they perceive math. It's rigorous proof that these visuals aren't just a fun gimmick. They are serious, powerful tools for mediating learning and emotion.
But it didn't just boost the good feelings. This methodology also led to a massive 32% drop in self-reported math anxiety. By letting students connect different visual and textual ideas themselves, that paralyzing fear of making a procedural mistake is replaced by the actual thrill of creative problem-solving and peer validation.
Okay, Section 3, the heart of the achievement, strategic semiotic competence.
Let's break down the 4 pillars of this strategic semiotic competence, or SSC, because this isn't just about drawing a pretty chart. This is high-level representational decision-making. Step 1 is selection, intentionally choosing the absolute best visual or symbolic resources for an idea. Step 2 is coordination, connecting different registers so that, say, an algebraic formula and a geometric graph are telling the exact same story. Step 3 is justification, rigorously defending why they made those specific choices. And finally, Step 4 is adaptation, adjusting that mathematical message so any audience can easily understand it.
Now, mastering this competence gives students that epistemic agency we mentioned earlier. Basically, it's the superpower to translate highly abstract math into tangible, real-world meaning. They're no longer just reciting a textbook, they are building real connections. Think about it, having the agency to explain something as abstract as derivatives by mapping it directly onto the local city traffic patterns in Managua, that is epistemic agency in full effect.
Let's look at Section 4, skills achieved that go way beyond just numbers.
Check out these incredibly complex geometric tessellations that the students actually generated, right next to the MathFest 2025 logo. MathFest was the absolute climax of this whole journey. It wasn't just some standard university science fair, it was described as a deeply subversive pedagogical event. This was the exact moment students proved their 21st century skills, presenting heavily researched, visually stunning math projects to their peers and their community. They were acting as true producers of knowledge.
And to pull off projects of that caliber, students had to master some serious digital competencies. We're talking fluent coding in Python and MATLAB to simulate quantum states through geometric patterns. They utilized LaTeX for rigorous technical formatting and GeoGebra for complex digital modeling. They were tackling real-world phenomena like commercial expansion and demographic trends using the exact same professional-grade tools that data scientists and engineers use every single day.
You can really see this mapped out in this word cloud, showing the diverse digital tools they used. Notice how AI assistants like ChatGPT, DeepSeek, and GeoGebra AI are right there in the mix. The key here is that the natural integration of these AI platforms didn't replace the students' thinking, it augmented it. This perfectly aligns their academic training with the actual professional demands they're going to face out in the real world.
But here's the thing, the success of this paradigm wasn't just about the tech. Look at this data on collaboration satisfaction. Nearly 80% of students, 78.6% to be exact, positively valued their teamwork. The data rigorously backs this up, showing that the MHEA-M model creates a highly effective collaborative environment. It actively demands social negotiation, dialogue, and peer validation to drive academic quality.
And this direct quote from a student really hits the nail on the head. Teamwork improved the quality of the project. It completely humanizes all those statistics we just looked at, right? It's a great reminder that real, collaborative human experiences are the true drivers behind these academic breakthroughs. When students are empowered to explain complex concepts to each other, it profoundly fortifies their own understanding.
Which brings us to our final part, Section 5, Prepared for the Future.
Ultimately, the future of math education under this hybrid multimodal approach looks incredibly bright. The data points to huge pedagogical sustainability. In fact, 88% of the students explicitly said they'd want to repeat this exact kind of learning experience. It builds these robust, transferable mental schemas that students can carry into entirely different disciplines. It skyrockets their self-efficacy and confidence. It proves that mathematics doesn't have to be just a rigid subject to survive. It can be a vibrant, living language for creating and transforming the world.
So, I'll leave you with this final, provocative thought. If we can empower students to be the true architects of their own understanding, using multimodal artifacts, AI tools, and deep collaborative reflection to actually master mathematics, what other complex global challenges could they learn to solve next? Thank you so much for joining me for this explainer. I really hope this deep dive sparks your curiosity to rethink how we learn, how we teach, and what our students are genuinely capable of achieving.